Alright, let's move on to Ethernet operation. If you've worked in just about any IT field for very long, you have probably heard someone refer to the OSI model. OSI stands for Open Systems Interconnection Model. The OSI model is a standardized, 7-layer stratified representation of the functions of a given data communication system. As network engineers, we specialize in layers 1 through 3, primarily of the OSI model, the physical, data link, and network layers. When someone refers to a layer 2 device or a layer 3 device, they are really referring to the layers of the OSI model. What is meant by this is that devices whose primary function is switching would be layer 2 devices because switches use MAC addressing or physical addressing. A layer 3 device is one whose primary function is routing because logical addressing, like IP addressing, is used at that layer. Other than these bottom 3 layers, we do not really concern ourselves with the OSI model because it mostly has to do with how applications communicate with each other. We deal with the physical and logical transportation of data across the network, so we let the programmers and server admins handle the rest. So Ethernet technology works in the lower 2 layers of the OSI model, the physical and the data link layers. At the physical layer, Ethernet controls the data streams that traverse the physical media on the LAN. Ethernet splits the data link layer into 2 sublayers: the logical link control, or the LLC, and the media access control layers, or the MAC layer. The upper layer of the data link layer acts as an intermediary between the data link layer and layer 3. When the LLC receives and processes data from layer 3, it passes the information to the lower layer, the media access control layer. An Ethernet frame header consists of the following fields: the preamble, the first frame delimiter, the destination address, the source address, the type or length field, the data field, the pad field, and finally the checksum field. You should take note and memorize these fields so you can identify them later because there may be questions on the JNCIA Junos exam about them. Ethernet is based on a standard or protocol called CSMA/CD. CSMA/CD stands for Carrier Sense Multiple Access with Collision Detection. This standard basically describes the rules under which Ethernet operates. Carrier sense means that Ethernet will detect whether or not there is a carrier or medium on which to transmit data when it is to be sent. In basic terms, it means that Ethernet will check if there is a cable plugged in to transmit data over before it actually tries to transmit the data. Multiple access with collision detection means that all network devices can talk freely as long as another device is not trying to talk at the same time. So Ethernet will attempt to detect if there is another device trying to talk before it begins talking. If 2 machines end up talking at the same time, there will be collisions. Collision detection will discard corrupt packets or frames and wait a random amount of time before retransmitting them. Bear in mind that CSMA/CD is a deprecated technology and is only used for backwards compatibility on half-duplex Ethernet. Full duplex Ethernet no longer requires CSMA/CD. Alright, let's move on to the next video where we will discuss connection-oriented and connectionless protocols.